To solve one-step equations, you actually need to get the variable all by itself, and we use something called inverse operations. A lot of times I'll just be referring to that as doing the opposite. If x is having 2 added to it, how about if we just come through and subtract 2? Well, 2 minus 2 is 0, and that's the x all by itself. But tell me, would x equal 10? I don't think so, because 10 plus 2 would be 12. So I know that x is not 10. That brings us to a little bit of predicaments. Ah, yes, see, this left side of the equation is supposed to be balanced or equal to the right side of the equation. So if I suddenly made the left side smaller, or took 2 away from it, I better take 2 away from the right side so they're both the exact same amount, so they'll still be equal to each other. What's 10 minus 2? 8. Let's go check our answer. I did have the equation originally as x plus 2 equals 10. Now, after we did the inverse operations, we're saying that x is equal to 8. So let's just put an 8 in for that x. What's 8 plus 2? 10. So 10 equals 10. Now I know most people, I would dare say 99% of the people in the world could probably look at this and go, the answer's 8, without having to do any type of inverse operations. That's not why I'm teaching you this. I'm teaching you this so that we can get a sound algebraic base to grow from when we get to a lot more complicated equations that have decimals and fractions and distribution and combining like terms and everything else. So use these inverse operations to learn how to do this. What's this type of equation talking about? Well, anytime that the number is sitting right beside a variable, it's actually multiplying. So negative 3 is multiplying some unknown number, and its result is 21 for the product. What's the opposite of multiplying? Dividing. So that's going to be our inverse operation. Since the x is on this left side, we've got to get this negative 3 away from it. It's bound together with multiplication, so we're going to divide. What's negative 3 divided by negative 3? Positive 1. Now, you tell me, what's 1 times x? Well, 1 times anything is itself, so 1 times x is x. We don't need to write the 1. It doesn't really cancel out this number, but what it does is it makes it a positive 1, and that's okay to have in front of the variable, and there's no need to write that. But since the left side of the equation has been reduced to just x, and how do we do it? We divide it by negative 3. We got to come back for the right side of the equation, okay? Divide it by negative 3. X is going to be negative 7. Let's check it to see if we're right. Negative 3 times negative 7 equals positive 21. Is that correct? Yeah, 21 really does equal 21. Moving right along, let's take a look at this one. X is being divided by 4. Okay, a lot of times people look at this setup here, and it just really disturbs them. What's going on? I don't know. I don't know what's happening. Well, any type of fraction is actually division. So just think of it as some unknown number is being divided by 4, and its quotient, or its answer, is 16. What's the exact opposite of division? Multiplication. And this makes it really easy. Just multiply it. If we're dividing by positive 4, let's multiply by positive 4. And basically it's the idea of multiplying reciprocals. 1/4 times 4 over 1 will equal 1. And so we know that 1 times x is x. That's the reason that the x is suddenly freed up there. But if I multiplied the left side by 4, I better multiply the right side by 4. So x is equal to 64. Let's go check to see if we're correct. 64 divided by 4 equals 16, so yeah, we're correct again. If you get the wrong answer, your check is not going to render you a true statement, so that's the reason we always go through and check it. Now, that being said, let's go through and do a practice and check to see if you can do it on your own. Here's 4 problems. Go ahead and check them, because I'll check all of them for you. And when you're ready, hit play, and we'll see how you did. These are the 4 basic types of one-step equations you'll see. All right, so here's number 1. X is having negative 2 added to it. It's really all we need to do is get rid of the negative 2, so let's just add 2 to it. Negative 2 plus 2 is 0. So there's the x, and we just add 2 to the right side, and we now know that x is equal to 57. And you tell me, negative 2 plus 57 equals 55. Is that true? Yes, it is. So aside from the fact that my 5s look awful, we're done with that problem. What about this one? Number 2, let's scroll down. Negative 4x equals negative 44. Well, there's the multiplication, so let's use division. Negative 4 divided by negative 4 is positive 1. 1 times x is x. Now we can divide this by negative 4, and we get an answer of 11. So negative 4 times 11 equals negative 44. Is that true? Yes, it is. So we know that we've got the correct answer. What about number 3? Y minus 8 equals 13. Well, since y is subtracting 8, how about we add 8 to both sides? Negative 8 plus 8 is 0, so the y is now free all by itself. And 13 plus 8 is 21. Now you tell me, 21 minus 8 equals 13. Is that true? Yes, it is. And finally, our very last one, k is being divided by negative 3. So let's just go ahead and multiply by negative 3. That frees it up. At least that makes a 1. Positive 1 times k is k, so we're done with that side. And now let's just multiply the other side by negative 3. 10 times negative 3 is negative 30. Plug it into the equation, see if it's correct. Is negative 30 divided by negative 3 positive 10? Yes, it is.